This tutorial will show how easy it is to perform an analysis of stage construction using the nonlinear capabilities of SAP 2000. We start with a simple 3-story, 2-bay frame, where each story will represent a stage of construction. We will remove the center first floor column in order to create a transfer girder. This girder will be susceptible to stage construction because it carries gravity loads from the floors above. The key to doing stage construction in SAP 2000 is to identify each stage as a group. In this case, each story or stage will be represented by a group. We select all the objects associated with the first story and will assign them to a group called Story 1. We will repeat this process for each story, selecting and then assigning the objects to a new group. Next, we review the static load pattern. For this example, we will use only the self-weight dead load. Next, we go to the Define Load Cases command. We will delete the predefined modal case as we will not be doing any dynamic analysis. To the dead load case, we will add an additional case for the stage construction. This case will be named Staged Con, and we select the nonlinear stage construction option under the analysis type. We will add 3 stages under Stage Definition. We have no time-dependent effects, so durations may all be 0. We highlight Stage 1, and under the Data for Stage 1 area, we select Add Structure, and then click Story 1 in the Object Name list, and hit the Add button. Next, we go back to the Operation list, and click Load Objects if added, then Story 1, with a load pattern of dead, and a scale factor of 1. Click the Add button. This tells the program to first add the structure and then the loads for the first stage. We repeat this process for the other 2 stages, adding the structure and then the loads. Click on the Modify Show button for the results saved, and select the end of each stage option. This allows us to display displacements and forces for each stage. We now have a linear static deadload case and a nonlinear case representing the stage construction of 3 stories. We are now ready to run the analysis. However, first we will change the 3D view to an elevation view to match the right window. Now we can click the Run Analysis button. And after the analysis completes, the dead load case deformed shape is displayed in the left window. In the right window, we will display the deformed shape from the staged analysis cases. We select Stage Con case and Step 1, which is at the end of Stage 1. Verify the scale factor is set to 300 to match the scale on the left. Next, we add the second story with Step 2. And then the top story with Step 3. A right-click on the middle joint for the linear case shows a displacement of about 0.2 inches. While the same location in the nonlinear staged analysis gives a result of almost 0.4 inches, nearly double. Next, we change the left window to show the moment diagrams for the linear dead load case. In the right window, we will again show the results for the staged construction case. Starting with Step 1. We can toggle up through the steps to see how the moment changes. At Step 3, the last step, the moment in the transfer girder jumps to 89.8 kip inches, more than double that of the linear analysis, where the entire structure works together to span between the columns. Also note how the moment diagrams are similar in each of the beams for the linear case, while the moments in the staged construction case differ significantly from floor to floor. This concludes this tutorial on nonlinear stage construction.